Welcome back to the second semester of college algebra. We're ready to kick off into some new areas. This first chapter we're going to be undertaking is all about polynomials. You've seen polynomials before, so this shouldn't be a big shocker to you. In fact, most of today's stuff should be very familiar. We are going to look at solving polynomials by a couple of our known methods we've used before. But first of all, before we do that, we need to talk about one more time what's a polynomial. Polynomial, of course, meaning many, implies that we have many terms here, although a polynomial can have just one term. So it's one or more terms, but the key thing is the powers or exponents have to be whole numbers. You can't have fraction powers, you can't have negative powers, you can't have some expression over x cubed, you can't have any variables in the denominator. It's what we think of as nice, normal-looking algebra. So we're going to try to solve these by factoring, and part of this is actually going to be a review of what you just did on the semester final, and you'll discover that we hopefully remembered that perfect squares, when they're subtracted, factor with conjugates. Perfect squares that are added don't factor at all. You're stuck with what you've got. And then perfect cubes is, of course, our square multiply square. The binomial stays the same. You keep the minus in the middle. And then we do square, multiply the two terms, and square. Signs are such, if the binomial is a minus, this first one's a plus. And, of course, the last one's always a plus because you're squaring. A cubed plus b cubed is exactly the same thing, except we do a plus b, and then we square, multiply, and square. Three terms, of course, we know we're going to unfoil it. And four terms, we're going to work with grouping. So that should all be old hat by now. And I'm going to cut right to the chase and get to some situations that are a little more complicated for us to deal with. So in this particular case, they might give you a polynomial equation which looks like the following. 3x cubed plus x squared equals x to the fourth plus 3x. Okay, they want us to solve this equation, and of course whenever we solve and it has an exponent, we know we have to have it equal to 0. I want to get it equal to 0 and in order from highest to lowest power. I would prefer that first term be positive, so I'm going to move everything to the right-hand side so that I get x to the fourth minus 3x cubed minus x squared and minus 3x. Okay, now hopefully you remember the number one first rule of all factoring before you ever try to apply a rule to it is to go, is there a common factor I can pull out? And of course there is. In this case we see we could pull an x out, which will reduce this down somewhat. Now you're looking at an expression with four terms, and how do we factor a four-term expression? Well, of course, we group. So we're going to group first two and last two. The x that we pulled out is going to remain out front. I'm going to put it outside a big bracket to remind myself that it's still multiplied. Okay, the first two, I could pull an x squared out and be left with an x minus 3. The second pair really don't have anything I could pull out, except remember you need to pull a sign. So in this case, I would pull a negative 1 out. And, okay, somewhere, whoops, Mrs. Meyer did indeed miscopy that problem. That was x to the fourth. Nope, take that back. That was the wrong spot too. Where did I miscopy the problem? That's a really good question, and I'm not seeing where I miscopied the problem. Well, oh, it was supposed to be a plus 3x there. Sorry, I didn't move the 3x to the other side. So now I would, if I pull a negative 1 out, I would get an x minus 3. And of course, we all know that in order for grouping to work, I had to get the same quantity both times. I had to get an x minus 3. Now remember, you're only halfway done factoring this, though. You have to then also go, what can I pull out of those two groupings? And I'm pulling out the x minus 3, which leaves me with x squared minus 1. Now, the difference here with these is we are trying to solve for x, and so you're not done yet. Yes, you've got created some factors. You're actually not even done factoring yet. Because you should go, oh, wait a minute. I have a two-term expression with an x squared. Is that perfect squares or perfect cubes? And of course, your answer would be, well, one's a perfect square, it had a perfect cube, but since it's x squared, yes, I could factor this as perfect squares, which means I'm doing conjugates. That's x plus 1 and x minus 1, so that one goes even farther. And then last but not least, if I set all my factors equal to 0, I'm going to get 0, 3, negative 1, and positive 1. Okay, big hint, my original problem started with x to the fourth, and look out, I got 4 answers. That isn't always the case. There are always 4 answers. Sometimes some of them are imaginary. We will get some of the imaginary ones in some of these problems. Okay, moving on to a couple other examples here. Mostly I'm worried about the tricky ones that cause people issues. If I said solve that by factoring, okay, you might say, well, just add 81 and do the fourth root. You can do that, but you're not going to get all 4 answers. You need to try to factor it. And so you would look at that and go, 2 terms, is it squares or cubes? Well, x to the fourth can't be a cube, so it's got to be a square. So yes, I'm going to factor it with conjugates, x squared and x squared, and then of course plus 9 and minus 9. Now, because I still have exponents, can I factor farther? Well, x squared plus 9, that's squares that are added, that won't go any farther. But the x squared minus 9, that's still a difference of squares. That'll go conjugates again, and I'll get x minus 3 and x plus 3. Now, that's as far as my factors go. I need to solve my factors, including the x squared plus 9, which is going to give us a somewhat strange answer. I'm going to subtract 9, square root it, which is going to leave me with plus or minus 3i. Don't forget, I is still with us. Of course, the other two are going to solve relatively easily, and we're going to get x equals 3 and x equals negative 3. So there are, once again, 1, 2, 3, 4 answers, because the plus or minus counts as 2. Okay, and then a problem with even a bigger wrinkle to it. Suppose I gave you x to the 6th minus 64. Once again, 2 terms. Is it perfect squares or perfect cubes? Well, it's kind of both. 64, we all know 64 is 8 squared. It's also 4 cubed. X to the 6th is a power of 2 and a power of 3. So you actually can work this problem either way. I would probably recommend it's easier if we do squares first. So ask yourself, what am I squaring on each of those? To get 64, of course, I'm doing 8. But to get x to the 6th, I have to be doing x cubed squared. So therefore, since I'm doing it as perfect squares here, I'm doing conjugates. And so I'm going to have x cubed plus 8 and x cubed minus 8. Now, here's the wrinkle. And by the way, sorry, that was supposed to say equals 0. I'm not done yet. I could solve those factors. I'm going to get 2 answers. They're supposed to be 6. So I'm not done. You should now look at it and go, well, hey, those are now perfect cubes. So I can now do the square multiply square. It's going to take a binomial and a trinomial, and then another binomial and trinomial. Okay, x cubed plus 8, I'm cubing x, and I'm cubing 2. I keep the plus sign. And then I do my square. Change the sign and multiply, and square. Same thing over here, except I'm going to have x minus 2. So I'm going to square, change the sign, multiply, and square again. Okay, now that I've got this far, I'm supposed to solve these. Okay, the trinomials, if you'll recall, the trinomials that come from the cube rule never factor farther. You will not be able to get those trinomials to unfoil. The numbers just won't work, the signs won't work out right. So I can solve, the x plus 2 is going to solve, I'm going to get x equals negative 2. And this one's going to give me x equals positive 2. But how am I going to solve those trinomials if I can't factor them? And yes, I hear the moans and groans out there. I am indeed going to do our favorite, the quadratic formula. So, negative b, 2, plus or minus, square root of b squared is 4, or ac, all over 2a, which is going to give me 2 plus or minus 4 minus 16 would be negative 12 over 2, which of course means I can break that down and reduce this puppy. So I'd have 2 plus or minus, I believe that becomes 2i squared root of 3 over 2. Am I done breaking it down? No, because they are divisible by 2 as well. So now I have 1 plus or minus I squared root of 3. How many answers is that? That's 1 plus I squared root of 3 and 1 minus I squared root of 3. So that's 2 answers. I already know I've got x equals negative 2. I've got x equals positive 2. So there's 4 answers. And if I solve this other trinomial, I'm going to get answers 5 and 6. And of course, you're going to realize that this is going to be nearly this exact same thing that I just got, except I have a negative 2 in front. So this is actually going to simplify down to be just the exact same thing as the answer I got on the other one, except I'm going to have negative 1 plus or minus I squared root of 3. Patterns like that are actually quite typical, where answers are simply a different variation with a positive or negative sign. And that would make 6 actual answers. 1, here's 2, 3, 4, here's 5, 6. Okay, so that takes care of our solving equations by factoring. And we're now going to go in reverse a moment. Now that you can solve them by factoring, now I want to reverse the process on you. I want to give you the solutions, or the roots, the zeros. Remember, there are lots and lots of names for what we just found. When you solve an equation, you're finding all of those things. Many terms mean the same thing. So I'm now going to go reverse on you here, and I'm going to give you the roots of an equation. I'm going to ask you to find a possible equation that had these particular roots to it. And we'll start nice. Suppose my roots are 2 and negative 3/5. Those were the answers I got when I solved the problem. What equation did they come from? Well, if you'll recall, we do this method by simply doing reverse factoring. We just take a factoring problem and we work it backwards. So, if I had solved these, I would have come up with x equals 2 and x equals negative 3/5 as solutions. So now I have to turn back into what factors did they come from? Well, x equals 2 came from the factor x minus 2. Excuse me. This one would not have come from a factor with a fraction. Instead, it would have come from the 5 being over here on the x. So it would have come from the factor 5x equals negative 3, or in other words, 5x plus 3. Once I get it turned back into factors, how do I find the original equation? And of course, yes, I simply need to multiply those quantities back together. And if I FOIL that, I'm going to get 5x squared minus 7x minus 6. I did the middle terms in my head, and there would be my new equation. Be sure you put an equal 0 on it, because it's not an equation if you don't have an equal sign. Now, why did I say a possible equation? Well, yeah, that's one answer, but I could take that equation by 2 times 2, and those would still be the roots. I could take that equation times negative 53,000, and those would still be the roots. So there's lots of possible equations that would be true. This is probably the simplest. Okay, let's put a little more pizzazz in your lives. Suppose I gave you some roots that came out of the quadratic formula, something like 3 plus the square root of 2 and 3 minus the square root of 2. And I said, okay, what's the equation those came from? That gets a tad trickier. There are several ways you can do this. I still prefer to work it as just a factoring problem, because there's a slick trick I'm going to pull here in a moment. Right now, I am just moving these over to get them equal to 0. Okay, and so if those are my factors, I need to multiply them back together. And you're going, but I don't want to multiply a trinomial times a trinomial. That's 3 terms each. That's a pain. You can do it. It'll be a pain. But there's this amazingly cool thing that happens. Notice that in both parentheses, the first 2 terms are identical. They're both x minus 3's. That's always going to happen. So rather than thinking of that as 2 separate terms, I'm going to think of that as one quantity. If I take x minus 3 times x minus 3, I'm simply going to get x minus 3 squared. I'm going to get 2 of them. Okay, notice I then have a minus square root of 2 and a plus square root of 2. Those are conjugates. So if what I have here, if I actually have an expression that's a conjugate, I know conjugates cancel their middle terms. So I don't have to do outers and inners here, which would be nothing but horrible. I just have to do firsts and lasts. So I'm doing firsts, and then I'm going to subtract, take square root of 2 times square root of 2, which is square root of 4, or in other words, 2. That is far, far simpler. So I just did firsts and lasts here. And that will always work, by the way. If an answer came out of the quadratic formula, they are going to be conjugates. Now you have to work it out, though. And you have to actually square x minus 3. True or false? I get x squared plus 9. Hopefully you're going, well, whenever she says that, it's always false. And yeah, because you have to FOIL that. There's 3 terms. U squared binomial. Remember, you can just double the middle. You're going to get minus 6x plus 9. Square root of 4 is going to be 2. So in reality, I have x squared minus 6x plus 7 equals 0. And there is my equation that comes from those 2 roots. So that's the second part of today's lesson. And then the third part is going to bring back something you guys have gotten really, really, really good at in the last month or so. We're going to solve polynomial inequalities. Okay, so what's she mean by a polynomial inequality? Well, exactly that. It's a polynomial, but in this case, it's going to have an inequality such as a greater than or a less than in it, not an equal sign. However, this totally, completely changes your ballpark. You can no longer just solve for x and say those are the solutions. Since I want this thing to come out greater than 18, there are many numbers I can put in there for x that make this true. There's not just 1 or 2 answers, but there's a whole range of answers. Your answers to these are going to be written in interval notation because it's going to be a whole range of numbers that make this true. So if we're going to have answers in interval notation, well, we still want to get this thing always greater than or less than 0. So I'm going to subtract the 18 over. Okay, and now I want it to be greater than or equal to 0. What does it mean to be greater than or equal to 0? Well, of course, greater than or equal to 0 means we need it to be positive. And what is the method I always use to figure out where things are positive and negative? Yes, I hear the collective groan again. Once again, it's our favorite activity. We are still testing points. It never goes away. So, you're going to have to factor it, find where it equals 0. Those are the numbers you're going to put on your number line so that you can test points. So, on these, you always set it less than 0 or greater than 0. And then you're going to test points. Actually, probably, let's add in their factor and test points. So, I need factors of 18. That'll get me a 3 in the middle. Well, I think plus 6 and minus 3 are going to do the trick. And so relatively easily, I can solve that and see that negative 6 and positive 3 are the numbers that will make it equal 0. Therefore, those are the numbers which go on our number line. Be sure you put them on the number line in numerical order. Okay. Here's where you can't say those are just the solutions, though. Here's where you have to look at and go, okay, I need to find where it's going to be positive or negative at. Is it, and yes, you guessed it, it's probably going to be the numbers on the ends or the numbers in the middle. So we need to test a point. And yes, 0 is the easiest to test, so 0 would fall in the middle interval. 0 plus 6 would be positive, 0 minus 3 would be negative, so that gets me a negative. Since these are all x's to the first power, and you will have to watch that, because if you have some factors with like an x squared or something, then you may not be guaranteed it's going to alternate, but in this case, yes, it's going to alternate. And so then I simply need to know where it's positive, which are these positives and these positives. Now, how do we know whether we want the endpoints or not? Well, in this case, when we're just doing polynomials, it's easy. If it's an equal sign greater than or equal to, then that means we can equal 0, so we want to bracket them. If it's a less than or a greater than with no equal sign, then you're going to parentheses them. So since we're only doing polynomials, it's pretty simple. And so consequently, my solutions will be negative infinity to negative 6 with a bracket, union with 3 to infinity. And a good time was had by all doing it. Okay, so that's basic solving of inequalities. You only have 2 or 3 problems of that. It's not anything super major, but you're going to have to factor it and test points like always. Enjoy.